Hello students, my name is Priyanka. So, I am your science teacher. Today I am here to start with the chapter number 4 or class 8. So, the name of this chapter is Metals and Non-Metals. So, let's start. Elements can be classified into the following two groups depending on their characteristic properties. Metals such as iron, copper, tin, silver, gold, etc. in general are hard, lustrous, good conductors of heat and electricity, can drawn into wires and beaten into sheets and have high densities. Non-metals such as sulfur and phosphorus in general are not so hard, brittle, are non-lustrous and poor conductor of heat and electricity. There are also certain elements such as arsenic, antimony and germanium which have some properties of metal and some of non-metals. They are known as metalloids. From the electronic viewpoint, metals are defined as elements which form positive ions by losing electrons. They contain 1, 2 or 3 valence electrons. For example, a sodium atom loses 1 electron, a calcium atom loses 2 electrons and an aluminium atom loses 3 electrons to form the respective positively charged ions. Non-metals are defined as elements which form negative ions by gaining electrons. They contain 5, 6 or 7 valence electrons. For example, chlorine contains 7 valence electrons and gains electrons to form a negatively charged chlorine ion. Oxygen contains 6 valence electrons and gains 2 electrons to form the negatively charged oxygen ion. Elements with 4 valence electrons are normally metalloids. The noble gases with 8 valence electrons do not form ions and cannot really be classified as metals or non-metals. However, since they are gases, they show the physical characteristics of gases. Occurrence of metals. All the elements in nature exist either in combined form or free state. When a metal is found in its free state, it is said to exist in its native state. For example, gold, platinum, silver, etc. such metals are called noble metals. In combined form, the metals are found in the form of various compounds like oxides, sulfides, carbonates, chlorides, etc. Most of the metals found in the earth crust are present in the form of minerals. All types of rocks, that is igneous, sedimentary and metamorphic rocks, contain some minerals. It is not always economical to extract a metal from its mineral. The mineral from which an element can be extracted profitably is called an ore. So, these are some ores of common metals: bauxite, aluminium, cuprite, copper, limestone, calcium, rock salt, sodium. So, now student, this is the picture. There are different types of ores as listed in the table below. So, in this table is divided into 4 parts: nature of occurrence, metal, name of ore, formula. Oxide ores: iron, magnetite, Fe3O4, aluminium, hematite, Fe2O3. Zinc, bauxite, Al2O3, 2H2O. Copper, zincite, ZnO. Cuprites, Cu2O. Sulfide ores. Iron, iron pyrites, Fes. Copper, copper glands, Cus. Lead, galena, Pbs. Zinc, zinc blende, Zns. Carbonate ores. Calcium, dolomite, CaCO3, MgCO3. Copper, limestone, CaCO3. Malachite, CuOH2, CuCO3. Chloride ores. Silver, horn silver, AgCl, sodium, rock salt, NaCl, fluoride ores, calcium, cryolite, Na3Al(F6), fluorspar, CaF2, phosphate ores, calcium, phosphorite, Ca3PO4(2). Occurrence of nonmetals. Like metals and nonmetals, too occurs in free as well as combined state. Gaseous nonmetals like nitrogen, oxygen and hydrogen are present in free form in air. Nitrogen consists 78% of air by volume, while oxygen consists about 21% by volume of air. These elements are also found in combined form. Nitrogen is present in all living organisms as proteins. It is also present in the soil in the form of various nitrogenous compounds. Oxygen is present in water in combined state and as oxide of various elements in the Earth's crust. Other nonmetals like phosphorus and silicon are found in rocks in form of phosphates and silicates. Sand or silica is an oxide, SiO2. Carbon occurs in pure form as diamond, graphite and coal. In combined state, it occurs as carbonates, hydrocarbons and carbon dioxide in air. Physical properties of metals and nonmetals. The metals and nonmetals differ widely in their physical properties. Some of these differences include physical state. All metals are found in solid state except mercury. All metals have high melting and boiling points except a few like gallium that melt even if placed on palm. Non-metals are mostly gases, but there are few like sulfur, carbon and phosphorus that are found in solid state. Bromine is a non-metal which exists in liquid state. Non-metals have low melting and boiling point. However, the allotropes of carbon, that is graphite and diamond, are exception to this because diamond is the hardest substance known and graphite has high melting point. Hardness. Most of the metals are hard and sonorous except a few metals like sodium, potassium and magnesium. Metals like sodium and potassium are so soft and they can be cut with a sharp knife. The hardness of metals allows them to be used in construction of buildings and bridges. The sonorous nature of metals allows them to be used in making bells. Non-metals are mostly found in gaseous state. Sulfur and phosphorus are found in solid state and are soft. The only exceptions in nonmetals that are hard are the allotropic forms of carbon called graphite and diamond. Diamond is the hardest known natural substance. Luster. All metals have a luster and shiny surface. The metallic luster makes some metallic like silver, gold and platinum expensive. Gold jewelry, they are used in making jewelry and other. They are used in making jewelry and other decorative items. Non-metals, which are mostly gases, are colorless. Iodine and carbon in the form of graphite are the only non-metals which have a shiny appearance. Malleability and ductility. Malleability is the property of metal that allows them to be beaten into thin sheet, whereas the ductility is the property of metal that allows them to be drawn into thin wires. It is because of these properties that metals are used in making wires, utensils, doors and windows, etc. Metals exhibit malleability and ductility, but non-metals do not exhibit these properties except graphite that can be drawn in the form of rods to make electrodes. The electrodes used in dry cells is made up of graphite. Conductivity. Metals are electron donors. They form positive ions, cations, by losing electrons, S. In a conductor, it is the flow of change that constitutes electric current. Therefore, metals are good conductors of electricity. Gold is the best conductor of electricity, followed by silver, copper and aluminium respectively. Metals are also good conductors of heat. The property of conductivity of heat and electricity have also made metals useful in making wires and utensils. Non-metals are poor conductors of heat and electricity except graphite, which is a good conductor of both the heat and electricity. Now, this is the table showing physical properties of metals and non-metals. So, serial number, properties of metals and properties of non-metals. 1. Metal are usually found in solid state except mercury. Non-metals occur in all three physical states, solid, liquid and gaseous. Number 2. Being solid, metal exhibit hardness except potassium and sodium, which are soft. Non-metals, if solid, are soft or brittle. Otherwise, they are liquid and gaseous. Diamond, however, is an exception. Third, metals have a luster and shiny surface. Non-metals, if solid, do not possess lustrous. Through iodine is an exception. 4. Metals exhibit malleability and ductility. Fourth, metals exhibit malleability and ductility. Non-metals are neither malleable nor ductile. Fifth, metals are sonorous. They produce sound when hit. Non-metals are not sonorous. Sixth, metals are good conductors of heat and electricity. Non-metals are poor conductor of heat and electricity except graphite, which conducts electricity. Chemical properties of metals and non-metals. Chemical properties of metals and non-metals. The chemical properties include the mode of action an element or compound executes in presence of other elements or compounds. Metals and non-metals differ in their chemical properties. These differences include reaction with oxygen. Most metals react with oxygen to form their respective oxides. Metallic oxides are basic oxides because when dissolved in water, they mostly form alkalis. However, metals differ in their reactivity with oxygen. Metals like sodium and potassium are extremely reactive, therefore, they are stored in kerosene oil to prevent them from directly coming in contact with air. Metals like magnesium, zinc, copper, etc. react when heated, and noble metals do not react with oxygen at all. So, these are some equations. So, 4Na, sodium plus O2 oxygen gives 2Na2O, sodium oxide. Sodium oxide, Na2O plus H2O is water, gives 2NaOH, that is sodium hydroxide. 2Mg, magnesium plus O2 oxygen gives 2MgO, magnesium oxide. The reaction of aluminium with oxygen is of importance because when aluminium is exposed to air or water, it develops a thin protective layer to oxide on its surface that prevents it from reacting with other chemicals. Therefore, the aluminium foil is used at homes and restaurants to wrap the food. Non-metals react with oxygen to form their respective oxide. Non-metallic oxides are acidic oxides because when dissolved in water, they form acid. Sulfur, S plus O2 oxygen gives SO2, sulfur dioxide. SO2 sulfur dioxide plus H2O water gives H2SO3, sulfurous acid. 4P phosphorus plus 5O2 oxygen gives when heat 2P2O5 phosphorus pentoxide. Now there is an activity to show that metals form basic oxides and non-metal form acidic oxide. Take a glass jar and ignite a magnesium ribbon. Let the residue of magnesium oxide formed collect in the glass jar. Add some water and use both the blue and red litmus papers to test the aqueous solution. Record your observation. Take a deflagrating spoon with little sulfur. Ignite the sulfur and place the burning sulfur in a glass jar containing some water. Shake the water in the gas jar after the sulfur stops burning. Test the solution formed using blue and red litmus paper. Record your observation. Compare your observation. The aqueous solution of magnesium oxide turns red litmus blue, showing that it is basic in nature, whereas the water placed in the gas jar with burning sulfur turns blue litmus red, showing its acidic nature. The above activity proves that metallic oxides are basic and non-metallic oxides are acidic in nature. Reaction with water. Metals differ in their reactivity with water. Some metals such as sodium, potassium and calcium react with water at room temperature, forming their hydroxides with evolution of hydrogen gas. 2Na sodium plus 2H2O water gives 2NaOH sodium hydroxide plus H2 hydrogen. Ca calcium plus 2H2O water gives CaOH2 calcium hydroxide plus H2 hydrogen. Metals like magnesium and aluminium react with hot water to form their oxide with evolution of hydrogen gas. 2Mg magnesium plus H2O water gives 2MgO magnesium oxide plus H2 hydrogen. 2Al, that is aluminium plus 3H2O water gives Al2O3 aluminium oxide plus 3H2 hydrogen. Metals like zinc and iron react with steam to form their oxide with evolution of hydrogen gas. Now Zn, that is zinc plus H2O G steam gives ZnO zinc oxide plus H2 hydrogen. 2Fe, that is iron plus 3H2O G steam gives Fe2O3 iron oxide plus 3H2 hydrogen. Metals like gold, platinum, etc. and non-metals do not react with water. Therefore, gold ornaments maintain their luster for years. They have no effect of acid, water and other chemical on them. Reaction with acids. Metals react with acids with different reactivities. They show the difference in their reactivity with water and oxygen. The reactive metals like potassium, sodium and calcium show violent reaction with acids when they react. They form the respective salts based on the acid involved in the reaction with evolution of hydrogen gas. 2Na sodium plus 2HCl hydrochloric acid gives 2NaCl, that is sodium chloride plus H2 hydrogen. Ca is calcium plus H2SO4, that is sulfur acid, gives Ca2SO4 calcium sulfate plus H2, that is hydrogen. Now there is another activity to show that hydrogen gas is evolved when a metal reacts with an acid. So for this, you have to take a test tube having some dilute hydrochloric acid. Add a few granules of zinc into the test tube. When effervescence is evolved, bring a burning matchstick near the mouth of the test tube and observe. Record your observations. When the burning stick is brought near the mouth of the test tube with effervescence, a popping sound is heard. The hydrogen produced during the reaction burns with a popping sound. The reactivity of metals to dilute acids decreases as we go down the reactivity series of metals up to hydrogen. The metals below hydrogen such as copper, silver or gold do not react with dilute acids because they are less reactive than hydrogen. They fail to displace hydrogen from the acid. The metals like copper react with hot concentrated sulfuric and nitric acid. Cu copper plus 4HNO3, that is nitric acid, gives CuNO3 copper nitrate plus 2NO2 nitrogen dioxide plus 2H2O water. Now there is another activity. So this activity is showing that metals differ in their reactivity towards acids. So for this activity, you have to take 3 test tubes with calcium, zinc and copper turning in equal amounts of mass. Add equal volume of dilute hydrochloric acid in each. Observe the Effervescence. Compare the result of the effervescence. With calcium, the reaction occurred violently. With magnesium, the reaction did occur but was not violent, and copper did not react with the acids. Metals mostly react with acids. Therefore, the people are advised not to store or cook the food containing acidic contents in metallic pots. The acid present in food react with the metallic surface of utensils and form compounds that can be toxic. Acidic food and pickles should be stored in plastic or porcelain containers. Nonmetals do not normally react with acids. However, sulfur and phosphorus do react with hot concentrated nitric acid. Sulfur reacts with hot concentrated nitric acid to form sulfur dioxide and nitrogen dioxide. S. Sulfur plus 4HNO3 nitric acid gives SO2 sulfur dioxide plus 4NO2 that is nitrogen dioxide plus 2H2O water. Phosphorus reacts with hot concentrated nitric acid and forms phosphoric acid along with the evolution of nitrogen dioxide. Now, P, phosphorus plus 5HNO3 that is nitric acid gives H3PO4 phosphoric acid plus 5NO2 nitrogen dioxide 2H2O water. Reaction with chlorine. The reactive metals react with chlorine to form their respective chloride. 2Na sodium plus Cl2 chlorine gives 2NaCl sodium chloride. Ca calcium plus Cl2 chlorine gives CaCl2 calcium chloride. However, the free chlorine present in atmosphere attacks the noble metal like gold also. 2Au that is gold plus 3Cl2 chlorine gives 2AuCl3 gold chloride. Some nonmetals like carbon and phosphorus do react with chlorine, but their mode of reaction with chlorine is different as compared to that of metals. You will learn about it in your higher classes. Now, Pu phosphorus plus 6Cl2 chlorine gives 4PCl3 that is phosphorus trichloride. C. Carbon plus 2Cl2 that is chlorine. It gives CCl4 that is carbon tetrachloride. Reaction with hydrogen. The reactive metals that is potassium, sodium and calcium react with hydrogen to form respective hydrides. 2Na sodium plus H2 hydrogen gives 2NaH that is sodium hydride. The reaction of hydrogen with reactive metals shows its non-metallic character despite being placed in the reactivity series of metals. The non-metals react with hydrogen also. Although their mode of reaction is different, they react with hydrogen forming covalent compounds. Now, N2 nitrogen plus 3H2 hydrogen gives 2NH3 ammonia. O2 oxygen plus 2H2 hydrogen gives 2H2O that is water. Reactivity series of metals. Metals differ in their reactivity towards oxygen, water and dilute acids. Some metals react vigorously and violently with dilute acid while others do not react at all. Therefore, the metals have been arranged in descending order of their reactivity. The most reactive metal is potassium. As we move down, the reactivity decreases. The metals below hydrogen do not react with dilute acids as they cannot displace hydrogen from an acid being less reactive. So, this table is showing reactivity series of metal. So, it's starting from potassium. Potassium, K, sodium, Na, calcium, Ca, magnesium, Mg, aluminium, Al, zinc, Zn, iron, Fe, lead, Pb, hydrogen, H, copper, Cu, mercury Hg, silver Ag, gold Au, platinum Pt. The difference in the reactivity of various metals becomes apparent when a reactive metal is added to an aqueous solution of less reactive metals. As you learnt before in displacement reaction that zinc when added to aqueous solution of copper sulfate displaces copper forming zinc sulfate such that the blue color copper sulfate solution decolorizes after the reaction. Zn, zinc plus CuSO4, copper sulfate gives ZnSO4, zinc sulfate plus Cu, copper. Similarly, when copper turnings are added to a transparent solution of silver nitrate, the solution turns blue as copper being more reactive displaces silver forming copper nitrate. Cu, copper plus 2AgNO3 that is silver nitrate, and it gives CuNO3 copper nitrate plus 2Ag silver. Now, uses of metals and non-metals. Metals and non-metals have great utility in our day-to-day life. The metals and non-metals in different forms are extremely useful commercially. The metals being malleable and ductile are very important in construction, from nails to iron bars used in reinforced concrete in association with cement to give firmness to structures. A very small quantity of iron oxide is also present in cement. The main constituents of cement are oxide of calcium and aluminium along with silicon dioxide. The metals being ductile and conductors of electricity are widely used in making electric cables. Nowadays, aluminium is preferred to copper as it is cheaper and light in weight as compared to copper. The metals being malleable and good conductors of heat are widely used in the manufacture of cooking utensils. The property of malleability and ductility of noble metals has also contributed to their use in making jewelry with metals like gold and platinum. Silver being a shiny metal reflects 90% of light incident on its surface. It is therefore used in coating the surface of reflectors in solar cooker and at solar power station. Because of its high malleability and less reactivity, and also because of thin layer of oxide formation on its surface, it is used for wrapping food items like chocolates, sweets, and medicines. The metals are also important constituent of a balanced diet. Calcium is required for the natural growth of bones and teeth and acts as a catalyst in different biochemical reactions occurring in the body. Example, blood, clothing. Iron is an important constituent of hemoglobin, which is responsible for transport of oxygen from lungs to body cells. Non-metals, just like metals, are equally important both commercially as well as for the proper functioning of the body. The oxygen present in the atmosphere is required by all living organisms for respiration. The chemical fertilizers are manufactured to meet the nutritional needs of growing plants. These fertilizers mostly contain three fundamental elements: nitrogen, phosphorus and potassium. Out of three, nitrogen and phosphorus are non-metals. Their requirements is fulfilled by the application of NPK fertilizers such as urea, ammonium phosphate, ammonium nitrate, etc. However, urea is preferred because its addition does not bring any change in pH condition of soil. Chlorine is a non-metal which is widely used in water treatment plants to disinfect water. Chlorine, on getting dissolved in water, forms hydrochloric acid and hypochlorous acid. These acids help to make the water free of germs. Now, Cl2, that is chlorine, plus H2O, water, gives HCl, hydrochloric acid, HClO, hydrochlorous acid. Iodine dissolved in alcohol is called tincture of iodine, which is commonly used as an antiseptic in clinics and hospitals. The silver salts are also used in photography. Sulfur is used in manufacture of sulfuric acid. Sulfuric acid is called the king of chemicals because of its extensive use in different types of industries like pharmaceutical industries, manufacturing sulfur drugs and industries, manufacturing paints and dyes. It is also used in the vulcanization of natural rubber, corrosion of metals. Metals react with elements or compounds present in their surrounding atmosphere. Their reaction with the constituents of atmosphere causes their wasting. Example, iron exposed to moist air undergoes rusting and silver exposed to air develops a blackish layer. This wasting away of metal layer by layer is called corrosion. It is necessary to take steps to stop corrosion of metals. It is made possible by preventing the contact of metal surface with air, moisture, and other damaging constituents. Now, painting. The metal surfaces, when painted, last longer. Therefore, the bodies of railway coaches, automobiles, and aircraft are painted to prevent their corrosion. Greasing. The application of grease on metal surface helps to prevent the contact of metal surface with air and moisture to prevent its corrosion. Bicycle parts are lubricated with grease to reduce friction and prevent their corrosion. Electroplating. It is the process of coating a thin layer of a metal over the other. The electroplating not only helps to prevent corrosion but also makes the metallic surface shiny. Iron is electroplated with zinc to prevent its corrosion. The coating of iron with zinc is called galvanization. The products of iron like door, knobs, bicycle, handles, taps, etc. are coated with chromium that not only extends their lifespan by preventing rusting but also make them look shiny and attractive. An extra mile. Phosphorus is highly reactive. It is stored under water. When phosphorus comes in contact with air, it burns into flames. Anodizing of aluminium. Aluminium is one of the most commonly used metal in making window, grill, door, table, etc. Because it is very light. The aluminium used for commercial purposes is anodized. In the process, aluminium as anode is dipped in a solution of sulfuric acid such that the oxygen produced react with aluminium to form a thin layer of aluminium oxide on its surface. Alloying. It is a common that the most effective method of preventing corrosion and extending a metal's durability. It makes the metal more resistant to chemicals and atmospheric corrosion and hence adds to the value of the metal. An alloy is a homogeneous mixture of two or more metals or a metal and a non-metal to make it resistant to corrosion and bring desired improvement in its properties. Alloying brings changes in the properties of metals, making it more durable and corrosion resistant. Some of the alloys are listed with their constituents and properties. Now students, are you able to see this table? This table is showing different alloys and their uses. So go through it and try to understand the concept. Now it's time for Reader's Digest. So chemical elements have been classified as metals, non-metals and metalloids. Metals that occur in the free state are called noble metals. Metals differ in their reactivity to oxygen, water and dilute acids. Non-metals like sulfur and phosphorus react with hot concentrated acids. So students, it's time to take your leave. So bye, we'll meet in the next class.